This is a quick overview of my project. I promise I'll try to go through it as quick as possible so the video doesn't drag on for 10 minutes. I was interested in the relationship between land use regulation and various city-based demographic indicators like age, race, ethnicity, income, etc. So I got land use regulation information from the Wharton Land Use Regulation Index, which is available here. You can see the URL here. Essentially, it's a one-number summary of how stringent land use regulation is in a place. It's compiled from 11 other indices plus an original survey work that the authors did. It was based on 2005 data but released in 2007 and has about 2,300, 2,500, can't remember the exact number, of different places in it. Then I pulled demographic data from Social Explorer, which is census data. Essentially is what they serve up there, and it's just really easy to download from Social Explorer, which is why I got it from them as opposed to from the census itself, from their API, from FactFinder, from anything else. It's just they serve it up very easily in multiple different formats, and it's very easy to kind of clean and work with. So, and they give you a nice little code book as well. So I downloaded these two sets of data, and then I, in R, I merged the data and renamed a bunch of fields, obviously, to make it a little bit more user-friendly. And then what I did, you can see here, is I classified the data into above, below medians, and then into quartiles, each of the variables of interest. Here you can see the variables that I was interested in: total population, population density, etc., etc., etc. Share over 35 means share of the population over the age of 35, share over 65, share of the population age over 65. Everything else is relatively self-explanatory, except for share dropped out as share of the population that dropped out of school. Some of those variables I didn't actually end up using because they seem duplicative, but yeah. And then again here down divided each of the variables of interest plus my target variable WRL URI into different buckets based on medians and quartiles. At the bottom here is just testing. A lot of these processes I was using automated kind of. I was using tidyverse, if anyone's familiar with tidyverse, and dplyr code. This is down here is the manual way of doing those same functions, and I just wanted to make sure the functions were actually I was using them correctly, so I did this to sort of test it out. Anyway, so after this, all my data was set and ready to go, and I was going to run it through 4 different types of analysis. The first type of analysis I used was just decision trees, and let me take us over to the results of those decision trees in Weka. So I did J48 and Hofdinger. Here are the J48 results. As you can see over here are my inputs. My inputs are those variables that I just showed in quartile form and then in median form. My targets I had in quartile form and then in median form. I varied the number of minimum objects in each leaf. I varied the confidence levels. I used an 80-20 split between training and test on all of them, and gave the accuracy on the test set here. And then all of these were pruned. So I decided that I was just going to prune to try to make the trees a little bit more simple. As you can see, the most accurate were typically mapped onto median targets, right? So yes, no, above or below the median WRLURI, and we're coming from quartile inputs. So the quartiles were 0 to 25%, 26 to 50%, etc., right? In each of those spaces. So I'm going to quickly show you a quick decision tree. I'll show you the most accurate here, which had a confidence level of 0.3. So pretty high there, and minimum objects of 25. So that actually I was pretty satisfied with. But it gives. Here's that trial. Oh, excuse me. Let me go to this one. Here's that trial. And so as you can see, average commute time, share of owner-occupied units, median household income, median gross rent as share of household income were kind of the biggest differentiators there, were the first branches that were used. And that kind of remained constant throughout all of these highest trials here. All the trials above 70% were using most of those variables in some form or fashion. So that gave me one piece of information that those variables are hugely helpful in predicting. So from there, I also did some Hofdinger trials. None of those got above 70%. We have the highest ones here at about 67%. I'll show you one quick trial there. And yeah, you know, we got a 67% accuracy. So it wasn't super great. It was hard with the Hofdinger to get anything above 67%. So, and hard to really kind of figure out what useful information it was really giving me. So I ended up just using mostly the J48 numbers. Then from there, I went into KNIME and did linear regressions and polynomial regressions. Here's my KNIME workflow. It looks a lot more complicated than it actually is. As you can see, the top branch is my linear regression, and then polynomial regression. This is using all of the variables. This bottom branch over here is just using the variables that my linear regression told me was associated linearly. And so let me quickly jump over here, show you some of those results. So here are the linear regression coefficients and the p-values. So this kind of confirmed some of what we had seen in the WECA trials, in that there are, you know, the median household income is below the 0.05 p-value level. We have median gross rent is below that level as well. We have, you know, the share owner occupied below that level. So some of the more common ones. We also saw that, you know, share black alone was below that, below the 0.05 p-value level, and share over 35, share over 65. So we're having some other things that we know are linearly associated here. So that was helpful. And then there were some things that were just kind of not, right? Share Hispanic all, share white alone. We're way over that p-value range. And then total land area, total population, were over that as well. Population density was below it. So that was helpful. And then the polynomial regressions, this is a result of just the regressions that we saw that were linearly related. We did see some shifts here. So we see that share over 35 and share over 65 are likely not related under the exponent 2. And so that was that was helpful, but there were some here that continued to be related even in a polynomial regression. So median household income, median gross rent, average household size was not, population density was not, share black alone. Again, this confirmed that some of the top predictors that we saw in the WECA analysis are, you know, consistently associated, whether it's in linear regression or polynomial regression under an exponent 1 or 2, continue to be associated. That's kind of, except for share owner occupied, but median household income, average commute continue to be kind of very highly associated. Okay, cool. So from there, we're starting to have a much better understanding of our different variables here. And so the final thing that I did was a k-means clustering here. And the k-means clustering, so here's the results table of the k-means clustering. And what I did was I started with a k of 5. And then as I lowered the k, I noticed that, you know, I was starting to get a higher or lower rate of incorrectly clustered instances, which was really great. And I also started to notice that when I would do relative to class, the class being WRL, URI, I would start to obviously get a lower number of incorrectly clustered instances. So I started to do that. I know that's not like a purely explorative analysis because I'm doing it relative to a class. It is, but I thought that it was useful in terms of getting me kind of better results here. One other thing that I noticed was that as I lowered my attribute size, I would also get better results. And so I'm going to quickly show you, let's see, I'm going to show you, I think it's trial 15 that I'm going to show you that had one of the two best, tied for the best results. And trial 15, here it is. And as you can see, the two attributes that were used were median household income and average commute. So again, we're seeing kind of the same variables pop up as really strongly associated. And so that kind of remained stable as I kept trying for two, as I lowered my numbers of k, lowered my k, and lowered my attributes. These two variables kept on being the variables that popped up. So essentially, what the analysis there's a lot of things in this analysis that obviously could be improved. You can't do everything in a project like this. But one of the first things that, to note from it is that the data, I don't think this data set can really highly accurately predict stringency, right? We got our best results about 70 to 72% accuracy. That was in the WECA. We got in the J48. In the Hofdinger, we got about 67%. With clustering, we could get about 65%, a little over 65%. So, I mean, it's much better than a coin flip, but it's still not super great. So there's probably some thought to be done on what other data would be useful here. Among the attributes used, there was a subset, this is the second point, that proved to be most valuable. Average commute, median household income, median gross rent is share of household income, and share of owner-occupied housing. Median gross rent is share of household income. I'm not sure how valuable that is because it is so highly associated with median household income. Actually, maybe not. That's one that has to be, I think, that relationship teased out a little bit. But those variables seem to be super, super helpful. And then there was another subset of variables that I think are worthy of further study. So share of population with a bachelor's degree or more, share of population over 65, share of population that's black alone, and population density were helpful under certain conditions. And so the question is, what conditions would those be most helpful under, and what conditions would they be irrelevant? And then finally, kind of the project points to some interesting things that don't affect land use stringency. One thing that surprised me was that the share of population that was black alone did have predictive value, but the share of population that was white alone and the share of population that was Hispanic alone did not seem to have much predictive value. A similar question can be asked of age, so the share of population over 65 seemed to matter much more than the share of population over 35. That could also be something where if we looked at the share of population between 35 and 65, that might matter. So there's different ways to slice and dice this that I think would be helpful. So I think this project sort of fulfilled its sort of basic aims, is try to uncover what variables were most helpful in predicting. Did see some patterns there across these different analyses types, and I think offer some questions for further analysis on this. I'm going to be doing more analysis on this just for my own interest and for my own continued dissertation work. But this was a really helpful start. So thank you for the class, and thank you for your time in listening to this. I'm going to quickly shut this down.